So before I get started, I want to have a quick show of hands. Who of you consider yourselves a Java developer developing code every day? Awesome. What else are the others doing that are not? What are you doing? I'm pointing at you. You didn't raise your hand.
I'm a postdoc, so programming is just a hobby for me.
Just a hobby? Well, it's a good hobby, though. Any testers in here? Any performance engineers? Yeah? Performance testers? Yeah? Cool. Anybody that is responsible for operations, for running an application like we heard before from Gravity? Being afraid of deploying something if something goes wrong? Yeah?
Yeah, we're deploying software every couple weeks.
Cool. Nice. Anybody outside of Java? Is anybody there to go towards the Microsoft space? Yeah? It's a good product, right? It's a good stack. Yeah? You should not be afraid of them.
I'm not afraid.
Yeah, me neither. I run my stuff on Windows, and I'm still using IE as my main browser. By the way, can you hear me in the back, or do I need to speak up louder? Fine? OK. Perfect. So I want to talk about Java and performance, the biggest mistakes that I've seen. And the reason why I think I can talk about this is if I look at my brief history, the last 15 years, I've worked in the performance space. I started with a company called Segway. It's not the Segways, but we actually built performance tools, load and performance tools. So I was a tester actually on the Silk Performer testing tool, which back then, I know not many raised their hands when it was about performance engineering, but back then we were mainly competing against LoadRunner, which is now an HP product. I did this with Segway. We later got acquired by Borland, might be a company that you're more familiar with. So I did this for 7 years. I started as a tester, then became a developer, later got promoted to become an architect, and then at some point in time, my CTO said, your development times, you're doing a good job, an okay job, but I think it's better if you actually help people using our tools, breaking applications, and helping them to figure out why they break. Because back then, about 10, 15 years ago, load testing was not only challenging to generate load, but even more challenging to understand the results of these tools. I remember my most exciting adventure that I had. I was helping the German unemployment office to run a large load test against their new system that they had to implement because they had a change in law. And I was asked to run a load test of 100,000 concurrent users. And it was very exciting for me. Unfortunately, the whole adventure stopped after 30 minutes because we broke the app with 100 concurrent users. Okay? And it was very hard for us to tell them what the problem was. That's why later on I followed my former CTO, who then said, you know what, we broke so many apps with our load testing tools, and load testing is becoming a commodity. Right? Nowadays, if you want to load test something, you go to one of these load testing services in the cloud, and you run as much load as you want for cheap money. So he founded Dynatrace because he said, I want to be able to trace requests from a load testing tool through a Java application. So actually being able to tell you why it is slow. Is it a bad database statement? Is it because you have misconfigured certain frameworks and they are throwing millions of exceptions that you never see? Is it you're allocating too much memory and therefore the garbage collector kicks in all the time? That's why he founded this company, which later got acquired by CompuWare, which you may also know from different fields. They used to be big in mainframe, which is something that most of us probably only read in books. At least I see some faces that are probably my age and maybe even a little younger. Anyway, since this is kind of my circle of life, since end of last year, we are back to Dynatrace. And as you can see, I wear with pride on my shirt. But that's pretty much all I want to tell you about my history of company-wise. But these 15 years allowed me to see a lot of applications out there. And what frustrated me about it is that every time they failed for similar reasons. And so my mission now is I want to be able to speak in front of people, drink beer, obviously, because that's a nice incentive. But I speak in front of people and tell you about the problems that I see so that you don't make the mistake again. Unfortunately, I assume your code that you've created, maybe yesterday, maybe a year ago, I'm sure suffers from some similar performance problems. OK? Now, also a little thing that I want to tell you now. You've heard me talk about 2 or 3 minutes. And you can probably guess that my accent is not from here. Does anyone want to take a guess where I'm from? Close? Austria. Yeah, Österreich. Here we go. So I'm from Austria. And typically the story is when I'm in this part of the world and I mention that I'm from Austria, then I very often get the feedback, oh, Sydney is such a lovely city. And then typically I need to remind people that there are no kangaroos in Austria. I think the only kangaroo we have is in the zoo in Vienna. Then typically I say, well, you know, where we are really from is this place. It's a very small country in the heart of Europe. 60% of the country is covered by the mountains, by the Alps. And then people typically say, ah, now I know what you're talking about. The Sound of Music. Okay? Who has seen The Sound of Music or heard about it? Yeah, a lot of you. If I asked the same question in Austria, I would not get a single hand. Just an FYI, a little spoiler alert. At least, I mean, only the people I think that make a lot of money on the tourists that come to Austria know about it. It's still very beautiful there. So instead of singing in the Alps, we actually have our Conchita. I'm not sure if you heard about her. I think she was actually on Letterman and some others. She won the Eurovision Song Contest last year, which was a big event. It's the largest competition for artists, for singers. She won it last year. We couldn't believe it. That's why we actually hosted this event last weekend in Austria, because the winner always hosts it the next year. And I assume you're from Germany based on your accent. So typically Germans and Austrians, we have a love-hate relationship, a little bit. Like the big brother, little brother, we like each other a lot, but we don't really like to admit it. We love each other. Since last Saturday, we have something more in common. We are so-called 0 pointers, because we're the only 2 nations out of 27 that achieved 0 points in the Eurovision Song Contest last weekend. So congratulations. I'm not sure if you followed. Australia actually did pretty well. Australia, by the way, obviously is not part of Europe, but they were asking for 60 years to be part of that competition, and this year we finally let them compete. They ended up 5th or 6th. They were actually doing pretty well. These are some other things that we would like the people in the world to know about Austria. You know this guy? He ruled this state for a little while. I let you judge if he did a good or a bad job. So we have the Terminator, we have our Herminator, our ski star, we have Felix Baumgartner, who did the space jump, or the space capsule jump, the supersonic. Then I saw some Red Bull cans over there, Austrian product, even though the guys stole the idea from a business partner in Thailand. But anyway, Austrian product. Our national dish, the Wiener Schnitzel, it's breaded veal. We are very famous for our pastries and also for drinking a lot of beer, and this is exceptional good beer. But a lot of people come to Austria. And also what we have, those of you that have seen The Sound of Music, the scenery there is really beautiful. By the way, we are hiring, and all of these places are within an hour to drive from our office. So in case you want to relocate to Austria, we are searching for Java engineers. Hallstatt? You don't have to. No, we have a lot of international folks now. Who said that? Yeah. No, we have a lot of international folks in the office now. So migrate, yeah. It's I think we have something comparable to a green card, where if you are in IT it's easier, I guess, but it's a general European thing. Say it again if you're single. So, yeah. Beautiful ladies. All right. So I'm not here to give you a geographical lesson, nor am I here to show you a blank slide. The reason why I'm here is because I think nobody in here, whether you are a developer, a tester, or responsible for operations, wants something like this to happen. If you're responsible for a website, if you're responsible for gravity4.com or your services, if you're responsible for other big services out there that people want to use and it goes down, so this is a screenshot of Apple's developers portal to go down, then this is not a good thing. Because that means you're called in and you may broke something and you're responsible for fixing it. I guess the only people that are happy if Apple goes down is if you work for Google or Microsoft, as a fun fact. So we don't want this, nor do we want things like this. Is anybody doing mobile development? Hey, do you like your mobile apps to crash? No. Exactly. This happened to I'm European, so when I talk about football, I mean the game that they play with the foot and they hit the ball. This was the FIFA World Cup app 1 week before the World Cup last year. It crashed for 80% of Android users when they opened up the app and refreshed the initial screen to see the latest news. Reason, memory leak in an outdated Java library that they use to display the list elements. 80% of these users crash their app. Not a good thing. Why don't we like this? Because it leads to things like this, the famous war rooms. And war rooms look like a party like this, a big table with people around it, or not with beers, but with sodas, but pizza is the same, but it's not a fun environment. Has anybody been in a war room? And you're still smiling, but I'm not sure. You probably don't enjoy the fact that you are there. And potentially, it also leads to things like this. Press coverage, but the ones that your marketing department doesn't want you to have. Like FIFA scores an own goal with buggy mobile app, or Facebook goes down, sets off panic or delight, depending on how you see it. Delight probably for Twitter, because then the whole social life from Facebook users went over to Twitter. And also things like this. This is a screenshot of the Google Play Store for the FIFA World Cup app. And I know it's a little hard to read, especially for the people in the back, but everything that is circled here in red has not nice things to say of that app. And you that raised your hand with mobile, if you have a great idea, you invest a lot of time and push it out there and you get this feedback, this is not good, because nobody will use your app, but will just go to the other app that is also delivering a similar service. I guess we know all that. The question is, why does this happen? Okay, and I told you, Kevin Spacey, right, in House of Cards, he also asked the question. I'm sure some of you have seen House of Cards, maybe. He asked himself the question in the beginning, why wasn't he put in the position that he deserved? I told you I started as a tester and then became a developer. And I can refer very well to this image here, and I'm sure you can too. I know it's a little hard to see from the guys in the back, but I remember when I was a tester, I did something that every developer was scared about. I found something that kept him from doing the cool stuff, from developing new features, because I found bugs that filled up his inbox. And the other thing is, always when I found a bug, it was, and I'm sure you get a lot of maybe bug or defect reports, not bugs, defect reports, and it's very hard to reproduce. So you typically say something, I found a problem, but on the other side, well, I can't reproduce. It works on my machine. Typical scenario. I'm sure you can relate to that. Why are you testing on Internet Explorer? Nobody uses IE. It works on my Safari or my Chrome. So we're explaining a situation to somebody that needs to fix it, but they have a total different view because I'm blocking you. And later, when I became a developer, I was on the opposite side. And I hated the testers, but I could relate to them because I was a tester before. So I think because of this, because we are scared of these bugs that they find, I know it's a little hard to see, but the closer we get to release, it feels as a developer like this, we're chased by the testers. And if we're very close to release and we have no chance anymore, then we do things like this. Like the guy from the Dos Equis commercial. I don't always test my code, but when I do it in production. Who of you can afford to do testing in production? Okay, nobody. Who knows that? Who has done this before to deliver code knowing that there are issues in there? Every day, right? I know, because we are on deadlines and we have to push this thing out, and we just hope and pray that we get time later on to fix it. The problem is that this attitude leads to 80% of development time in the US alone last year spent in bug fixing and not creating new cool features. There's another number, 75% of code ever written actually never makes it to production, which also means a lot of bugs never make it to production. But it's amazing. And last year alone in the US, bug defects contributed to 60 billion of defect costs. If Amazon goes down, if Facebook goes down, they lose a lot of revenue. So most of this is not actually your labor cost sitting in the war room, but lost revenue, lost reputation. Now what's interesting, and this is kind of my transition over to where I want to show you some technical stuff. I know this is all marketing bullshit, blah, 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 or something that you already know. I work with a lot of customers, a lot of companies out there, and as I said in the beginning, I'm very frustrated that every time I do a performance analysis on code, 80% of the problems that I find are only caused by 20% problem patterns. It's always the same things. And that's what I'm here for, because I want to tell you some of these stories so that you can avoid it, so that you can go back tomorrow to your workspace, or if you're really too excited, maybe tonight if you go home, and try to find these and make sure you don't put them in, or you haven't put them in already. So what I'm telling you, stop waiting for bug reports. It's time to look behind the scenes. There's more going on than you think, and things might be a little different than you actually think. So I want to show you 6 situations on why certain things failed, how to avoid it, and also I'm a very big fan of metrics. I'm a big fan of metrics because metrics tell me something. They tell me what the status is and not just a good feeling, because right now I have a good feeling. If I drink 5 more of these, I have a different feeling about it, probably. Metrics never lie. If you measure the right things and if you know what you're measuring. And if you do it automated, you can prevent a lot of things from happening without doing a lot of manual work. By the way, question to the back. Can you see anything of this, or is this just blur? Yeah? And you can still hear me? Awesome. I always start my scenarios with an image that kind of reflects what this scenario is about. This guy here was a very, let's say, creative engineer, and he did something that we all like to do because we think we can do it better. We can reinvent the wheel. I'm sure most of you Java developers, we think we can write the next better Hibernate. Or if you're a web developer, we can write the better jQuery. But on the other side, it doesn't really make sense. It makes sense to use the existing components that are there and build something new on top of it. And a lot of people do this, but what I often see is that people blindly reuse existing components, blindly reuse frameworks without even knowing what they're doing. And the first example happened to myself. Last year, I took over a position within Dynatrace where I said, so we have a free trial product. You can actually go to our website and download the product, and you can play around with it. But what I said to my boss, because he said we need to push this out more, we want to tell people that we have tools. I said, if I do this, if I take over that role, I want to be able to go to meet you at a meetup like today, and you give me your business card, and I want to invite you for that free trial, and later on I also want to track how you're doing. So I need a report that tells me how many people I've invited and what their status is. I asked for this. Very simple, nothing fancy. I'm the only guy who looks at that report. Doesn't need to look pretty, but what it says, what it tells me, I invited 1, 2, 3 people. This is the status. I am the guy who invited them, and they already created a license key and all that stuff. And I asked the developer who implemented the backend service. All of his life, he implemented backend services. He never implemented a front end. But I asked him and I pushed him because I said, in 2 weeks from now, I'm at a conference and I want to have this feature available. So you as a developer, if I ask you to do something that you've never done before, and you don't want to tell me that, what do you do? This would be one option, ask people, but I heard something else. Who said something about Google? You Google it. So my colleague, he Googled HTML report based on 2 SQL tables. What he found was a sample project on GitHub using Hibernate, which is a cool thing, and he implemented it and everything was super fast. This report took milliseconds to generate, but every week and every day, every week and every month, this became slower until at some point in time last summer, I couldn't use this product anymore. The report took minutes to show me 3 lines. I went to him and I said, it doesn't work. He said, it works on my machine. Okay? And what we then did, we looked at what actually, and I hope that who of you has used Hibernate? Who of you knows how to look at the SQL statements generated by Hibernate? Good, similar amount of hands. So what we did, simple thing, we looked at the SQL statements being executed by his code to generate the 3 lines of report. And it executed 4,000 SQL statements to generate 3 lines. Because the sample that he used was a for loop where in the for loop he was iterating through every single object. Every time he accessed an object, Hibernate loaded it, and then he put an if statement in the loop saying if this user is invited by Andy, then print it out to HTML. And the thing is, Hibernate is a great framework, but as all of you know that raised your hand, there's different ways of solving that problem in Hibernate. By Hibernate only executing a single statement to query exactly these objects that I've invited. But he reused a framework that he had no clue about, and I didn't give him the time to actually look into it closely. And I know even those of you that all raised your hand, that you know how to look at the SQL statements, I at least want to tell you, please do it more frequently, because you don't want to miss things like this. Because this is, whether it's Hibernate, whether it's Spring, on the .NET side, we also have the entity framework. There's a lot of OR mappers out there. You can make the same mistakes in every technology, in every framework. And people simply forget about it, because they're put under pressure, and then it's close to release, and then nobody has time anymore. This is something that should not happen. And the reason why he couldn't reproduce it on his machine is because he had a sample database with 10 rows. Similar, very, very simple thing. Another example, and I hope I don't gross you out with this. What does this tell us? I guess a functional toilet, but the architect who came up with that plan, he probably didn't make the right decisions, right? Works well for guys, for ladies it's a little harder. Yeah, looks like Australia? So what I'm saying is not every architect makes good decisions. And this happened to me. I take a personal example. I told in the very beginning, I started with my first company as a developer, then as a tester, then became promoted to a developer, and later on an architect. So I was an architect for a new project, and I was never really educated in architecture. I had no clue about it, but I was put in charge, and I had to make decisions, and I'm sure I made the wrong decisions. And I'm not sure how it is with you. If you are starting in a startup and you are now responsible for everything, and you need to make the tough decisions, but I haven't learned architecture in university. I didn't go through a 5 years apprenticeship to know how architecture should really be done. I'm not sure about you. I did not. I made mistakes. Same things here. In this case, this is an example of a very large company that we all know, 2 letters, British, sells petrol. They had a project where 15 years ago an intern created an online room reservation system for the meeting rooms. To say, I want to see my 5 meeting rooms, I want to pick a time where I reserve it. 15 years ago worked well for one location, it became very popular, and the project that an intern started is now used across the whole organization worldwide. The developer is obviously no longer there. Somebody else took over the code. Now they have the problem that rendering these pages that show 5, 10 meeting rooms in that location take between 1 and 2 minutes. In production, they see high garbage collection time. The first assumption of the engineers that took over the project said it's probably bad garbage collection tuning. It has to be, right? Because if garbage collection is high, it's always bad garbage collection tuning. And they also pointed fingers to the database guy, because they said, we looked at the code that is rendering these 5, 10 rooms, and it's so simple, it has to be the database. In order to prove their point, and I'm sure you've done this maybe yourself, if you want to get some metrics, if you want to get some proof, if you want to do your own tracing and monitoring, you may build in your own logging. So what they did, timestamp before loading the data, timestamp after loading the data, printing it out to a log file in production, and then their point in proof was, yeah, on average we see 45 seconds being spent in that load data for Office. So it has to be, the problem has to be on the database. The guy who came to me was the database admin. And he said, this is the situation that he's faced with, but his tools, his database tools tell him every single SQL statement executes faster than 1 millisecond. It's the same scenario as before with a tester versus a developer, and now it's a developer versus a database guy. They explain the same situation from a total different perspective, using different tools to measure performance. What we did, we actually looked again closer into what actually happened. And I know this is a little hard to see maybe, but this is what we call a Dynatrace transaction flow. So we were looking at what is actually happening when somebody creates that report to show me these 5 meeting rooms. The request comes in Apache, goes over to Tomcat, and then goes over to, in their case, a Sybase database. And those of you that sit maybe in the front, even though you've never seen the screen maybe before, you may make out some numbers that should be very obvious what the problem is. Can anybody spot a number here? So these are the calls between tiers. This is the time spent in a tier.
Number of requests to the database.
Exactly. What do you read there?
Like 24,000.
Exactly. They had 24,889 calls to the database in order to display 5 rooms or 10 rooms. It's a little excessive, just a little. It's a very similar problem pattern what I told you before with my Hibernate example, but in this case, what we actually figured out, first of all, we showed them all the database statements. This is a classical, I call it the n+1 query problem. The same database statement be called all over again, just with a different ID. Also, Sybase has a very, does anybody use Sybase? Okay, yeah, one guy in the back. Huh? Long ago. Sybase has this very interesting thing is if you take a database connection out of your connection pool, it always sets the security context on it. We set client name and then your current user. And we saw that this was actually called 12,444 times. So basically what the code did, they took out a database connection, executed a single SQL statement, and put it back. And they did this 12,444 times for a single request to show 5 rooms. Not very efficient, excessive to use your word. And also what's interesting, looking at the individual SQL statement execution as seen from the application, this was the proof that every SQL statement was really faster than 1 millisecond. So the database guy was right. Now the question is, why did it come to this thing? What we see here is what we call the method hotspot. So when our product or other profiling tracing tools, whatever tool you use, whether you use Dynatrace, whether you use New Relic, App Dynamics, I heard Wiley, even though I think Wiley is really first generation tool, or if you use your profiler, these tools tell you which methods actually take a long time. And what we could see here that most of the time was actually spent in hash table. We found out that the initial intern that developed that system had no clue about the database, but he learned something in school about hash tables. For every single request, he loaded the complete database into a big hash table. Okay? And now we know all laugh about this. But think about it. How much of the code that you are now responsible for is your own code? Can happen to you too. It's a big company. So he loaded everything into a hash table. And what we see here, this is the reverse call stack. So here we can actually see where data is actually called from or where these methods are called from. This guy back then, he created his own entity framework. So he had a room object and an entity, abstract entity object. And basically all of his implementation was to first load the whole thing into memory, and then basically the data source of the entity framework was the hash table. And then everything was disposed, again, after every request. That's why they saw such high garbage collection. Make sense?
That's why there's gun laws.
That's why there's gun laws. Yeah, I know. I hope still he's alive, and maybe he learned his lesson. Hopefully he's better now. He was an intern back then. He had no clue. So lessons learned. First of all, the custom measuring that they put in. In case you've ever put in something like what I showed before with the 2 timestamps, their measuring was actually wrong. Why? Because they had such high garbage collection impact that if the garbage collector kicks in between 2 method calls, obviously, you're measuring wall time or clock time. And they did not include the garbage collection time. So there are tools out there that can actually tell you how much time is really spent on CPU or actually in garbage collection. So that's one thing. And they just measured the overall time, but never had the idea to look at the number of SQL statements being executed. Also for you, never assume that you know what code is actually doing that you've inherited. And obviously for the guy, the intern, learn SQL and don't think hash tables are the solution to your database problems. Okay? Make sense? I know you're shaking your head. It is happening, and this is a big company. Man, I know. I'm a big fan of metrics, as I told you. The number of SQL executions, you should know how many SQL statements are really executed in the code that you're developing. Also, the number of same SQL statements, and there's two use cases for it. If the same SQL statement is executed multiple times in a single request, you can probably optimize that SQL, the n+1 query problem. If you look at a longer running time frame and the same statement is called every time, good candidate for caching. I see a lot of scenarios where frameworks store the configuration properties in a database, and for every single time somebody needs to load the framework or needs something, the framework goes to the database and loads the same value again, even though it never changes. So cache data. And this is another one, I didn't mention this explicitly before, connection acquisition time. Do you know what that is?
I think so. You get connection, you use it, throw it back. I said, open a file, close it, open a file, close it.
Exactly. And the connection acquisition time, however, so a lot of people look at connection pool utilization. So if you have a connection pool of 50, and if you have 100% utilization, what does that mean? No free connection. Is that a good or a bad thing? Why? Exactly. Why if there's no next request? Why if there's no 51st user that needs a connection? Then it's a perfect system. But if nobody needs the 51st connection, then it would be okay. So that's why I'm telling you, I mean, looking at the connection utilization is a good thing, but actually looking at the time it takes to get the next connection out of the pool. So how long does it take me to acquire, I'm not sure if that's the right word, acquire a connection from the pool? This is the more critical measure, actually. Because sometimes pools are highly optimized, and then 100% utilization is actually perfect. I agree with you. But still, if you look at the pool, and if you only need what's in the pool, and even if it's 100% utilized, but nobody else needs the next one that's not available, this is an additional metric that I tell people to look at. Do we actually need to wait in order to get the next connection? For your web developers out there, I know there's many web developers. If you look at your browser diagnostics tools, every browser has a set of physical connections to download resources from a domain. There we speak about the wait time. How long does the browser need to wait in order for the next physical connection to be available to download the 7th or 8th image of the same domain? That's similar. So you're actually waiting for a resource. So please remember these metrics. And maybe tomorrow when you go home, think about it. Yeah, this is a way, how can we measure this? Because I'm interested in it. I want to know if I make one SQL statement or 1,000. Next one. You call it cheating. I call it multi-threading. This came in recently, and I call it parallel or paralyzed. This was an organization, and they had a monolith application. Everything was running in a single app container. And then the architect had the idea, we need to do SOA. We need to rip everything apart and make it service-oriented so that we can scale any service as we like. They did it. It was a financial application. This is the transaction flow. And I know it's hard to see, especially from the back, but again, request comes in here, goes to Apache, goes to the first Java server, goes into a cluster of 8, goes to this database and also to an external service, to Siebel in this case. Now here are the interesting numbers. 12 minutes for a single web request under high load. It's for logging on to your online bank. Now because they split everything apart, everything used to be in a local container. So what they did, they defined certain interfaces that now became callable via RMI. Now they had 64 RMI calls from one JVM to the next. They had 130 calls to Siebel on 13 different background threads. Because basically what they actually did, so they ripped everything apart, and now the services, the individual ones that were now hosted in this cluster, every time when they were called, had to go to Siebel multiple times to get some state information or whatever information they needed. But they could not share the data anymore. That's why every service call that used to be called in a single JVM and they could share the data now was not able to share it anymore, and they had to multiply all these calls. Now, what I like, I know it's very hard to see, but I'm going to share these slides. This is what we call a pure path. So this is the actual execution of the code. We are able to trace, if you have a distributed application, we actually show you the call starts here and then it spawns off into multiple background threads and multiple JVMs. So we show you really everything in a single, we call it a pure path in a single trace. And what I really like about it, we follow calls across RMI boundaries. So this is the call in one thread, making the call, going over to the next JVM. And here we also see the different thread IDs. This is how we could figure out in their case that they were really executing every RMI call asynchronously. And because everything basically was then pushed back to Siebel, and Siebel was totally overloaded with a lot of multiple, with 10 times or how many more times traffic, everything was basically blocked. So they were blocking threads. They were consuming much more bandwidth on the network, obviously. They decided to actually be able to host a different service into different data centers. Therefore, you have the network traffic to consider. So what I'm telling you, the architect that made that decision to rip everything apart should not just think, I can rip everything apart. You need to really think about a new architecture. SOA doesn't mean ripping things apart on currently defined interfaces. Also what they had, they were using Oracle Coherence, and now Coherence was also pounded many more times because these backend services were all of them going into Coherence. And here's also the top hotspot object was actually object weight. And so the way this view works, we show you what is the top method, and if you click on it, here you see that who is calling it, and it was very interesting to see that Coherence, the Coherence API basically spent most of the time in waiting because Coherence was overloaded. So they just basically by making an architectural decision came up with a total different problem, a much bigger beast. Yeah, there's more on this multi-threading example. I'm flipping through this. What I want to tell you, it's very easy. This multi-threading, it's very easy for you to monitor how many threads you really use. I hope you all know how to get access to your JMX metrics of your containers, or in .NET, your Windows performance counters that .NET is exposing, or whether you work on other platforms and runtimes. So look at the threads in the different containers. Also, I know it's a little hard to see here with the bright light, but if you have a web server, any type of web server, with Apache, Nginx, IIS, always take a look at the threads, how many are idle, how many are busy. I've seen very crazy things here. So metrics, because I told you I love metrics, the number of threads your code actually uses, and also calls to APIs. How often do I call into Coherence? Do I call it once? Or now, after my architectural change, I call it 100 times because I split everything apart. Make sense? By the way, I know in the beginning, it's actually really warm in here, at least for me. I'm not sure how about you. Warm? Yeah. You can control how long I go. I have 3 more examples, but I don't want to bore you. So if is that okay? Keep going. Okay. But just tell me. Next example. Who knows this guy? Jeffrey. Those of you that don't know him, Game of Thrones, he's the evil kid. I would say that they put him on the throne. He was I think there's good kings and bad kings. He was deployed on the throne as I think he was a bad king, and he deserved justice, right? Or he got the justice. As with bad kings that do bad rulings, there can be bad deployments, or deployments that go bad. In this case, this is an example of an eBay-like platform. I say eBay-like because there is one use case where people like you can put their products on to sell it, and people like you, they can buy it. This was 2 weeks before Thanksgiving. This company ran a large-scale load test with LoadRunner, testing both scenarios, putting something on there and then looking at the report, how much did you sell at the end of the day, and like you that browse and buy something. And what they had in that test environment 2 weeks before Thanksgiving, the use case of you at the end of the day, figuring out how many items did you sell, hard to see. It took 42 seconds to get that report, and they made 1,600 database calls. So similar pattern again. Now the interesting thing is this team said, we're 2 weeks before Thanksgiving, and sorry, you are not as important as he, because he makes the real money, and you can wait 42 seconds for your report, because you only look at it once a day. They deployed this into production with very much confidence that everything else will go good. In production, the same load, the same use case for you now, the report took 5, almost 6 minutes. And what was very interesting is there were 3 times more database statements executed. So who can give me a hint on what the difference is between the, how can this happen? How can it happen when they actually executed similar amount of load here, but a different version here? Much slower and more database statements. The data was, so they took the data of the year before, and they haven't read the papers that much more is happening online. They didn't anticipate it.
Maybe all the containers are running the same thing. There might be more deploys or more containers on production. Where the code is deployed and all are doing the same thing.
That was not the reason, but could be as well. So one thing was that there was different data set, and they had a data-driven performance problem. So they were just loading, executing more database statements. But what was very interesting was this one. So what we always do when we look at performance, if you look at an application, there's a lot of stuff happening in there. And we always try to put it into layers. So the top layer here says web server. The light blue means I/O. In testing, most of the stuff was happening in I/O on the web server, which makes sense for a web application, because if you look at the website, most of the content is static. Images, JavaScript file, CSS, and that's all I/O that the web server is doing. The next thing was Hibernate, web services, JDBC, and their own code base. The same thing in production looked like this. First thing is Hibernate, next thing is Java class loading, then custom monkey and XML processing. No time spent anymore on the web server, at least not a hotspot. And the interesting thing is why this was so different could be explained by, again, looking at this view that we've seen before. The top method here, the slowest method, was java.lang class get interfaces, was reflection. And it was called by Hibernate's field interception helper. Okay? So what they did, went on Google, searched for a field interception helper performance problem, and the first thing they found was a Jira ticket saying, well-known performance bug in this version of Hibernate. Why is there a difference? Different version. So operations decided on the eve before Thanksgiving that they need to upgrade their production libraries. Yeah? So you're laughing about this now, but this is a company that most of you probably also know. It happens because they were scared. They said, we need to go to the latest versions, and therefore we just upgrade. So basically, the whole load testing that they did was bogus because they were testing a total different application. And the other thing was interesting. The XML stuff, it was also class loading, but they also flipped or switched to a different XML parser because somebody read this parser is much better than this one. I mean, for us, stupid things, but these things happen. And it's a reminder for everybody that even though this seems like common sense, people make these mistakes. Say it again, that should be different?
Different releases for business code and infrastructure code.
Yeah, I mean, but the thing is, you should only put stuff into production that you really test, and that includes your own code and everything around it. That's the whole thing. Yeah, you know, that's not true. As you said, it's not true. In this case, they had a regression in Hibernate in that version that they deployed. So, metrics, time spent in API, how much time do you spend in Hibernate, how much time do you spend in reflection, and how many calls do we have to that API. These are always metrics. If you start doing this and checking these metrics along your pipeline, before you check in code, when you do your unit tests, your functional tests, your performance tests, and you look at these metrics, you can automatically identify these regressions that might not be obvious yet, but if you look at these metrics, they can tell you that. Next example. There's one more after this, and then I'm done. What does this tell us? Boardroom, right? This is a room similar to this, boardroom, but the people in here all earn about 10 times more than we do all together. And the guy in the front here says, I think we may need a mobile strategy. Probably a couple of weeks before Thanksgiving when he heard in the news that everybody's making business online these days. So we need a mobile app. And here, the guy in the back who is tweeting and Facebooking, he said, sorry, did you say something? Kind of only half hearing it, and then basically what often happens is push without a plan. So I'm not sure if this happened to you, but somebody has a great idea and you have to have it yesterday. So please implement it. And in this case, this is an example that happened to a very large soft drink company. They're sponsoring the Super Bowl. And what they had, their marketing team had a great idea. They said, when there's parties like this going on around the globe, because it's the biggest sports event in the world, at least single sports event, I believe, then what we want people to do, we want them to do things like this. They should have parties and drink our soda and then take selfies. And they should upload the selfies to our website, so when then later on they see our commercials, everybody goes on our website, and then we show them the last 400 selfie uploads in a 20 by 20 grid. Okay? That was their idea to interact with their users. It's a great idea. If the screen is big like this, but if this is your mobile strategy, 20 by 20, then this is still a good idea, but you probably need to rethink it, and especially how you implement it. And I'm showing you one screen of a browser diagnostics tool with 2 metrics, and the 2 metrics should tell everybody that this is not going to work. In order to download that cool mobile app, mobile website, I had to download 20 megabytes on my iPhone 4, and it was 434 individual images. Because the way it was implemented, I had to download every single image at 20 by 20 as an individual file, and not in 2 by 2 pixels, but like in whatever, 400 times 400, and then my poor little thing had to scale it down. Okay? Exactly, that was my reaction too. Yeah. So, obviously a great idea, but the implementation was not the best. If we do something like this, any ideas how would we do this better? Thumbnails. So I would create, what I would do, nobody knows the last 400 uploads. So every 5 minutes I run a batch job and take random 400 images and create 3 images. A big one for the big screen, one for my laptop, and one for the small device. Then I save 399 round trips and a lot of data here. And the fun fact here is as you know, I'm not from here. This is my Austrian business phone. Data roaming in the US is 15 euros per megabyte. So in order to download this when I'm abroad, it's 300, is that right? 300 euros. That's $350. For a page, it doesn't really make sense to me. Okay? Make sense? And because I don't always want to pick on the people in the US, but also on the Europeans, FIFA.com, so soccer, football, their mobile website, the landing page of the mobile website, the largest element on the page was the FAF icon with 370 kilobytes. Okay? The FAF icon, for those that don't know, it's the little 32 by 32 icon on the top left of your browser, or if you pin the page to your home screen, it's a little logo that you see. 370 kilobytes, it was the full high-resolution image that somebody probably took from their marketing department and graphics department and just converted it into an icon. That's not a good thing. And so what I want to tell you, if you are a web developer, or I'm also talking to testers a lot, there's no excuse anymore to not look into these metrics before you check in code. This should not happen. Not to companies like this, and not to your company either. So, things you want to check, the number of images on a page, number of redirects is also a good one. I have some other stories on this, and the size of resources. Okay? Where are the web developers? Okay, come on, don't be shy. Are you already falling asleep? There's more beer later on if you stick it through the whole thing. So, please use your diagnostics tools and make sure these things don't happen. Last example, another football, Super Bowl from last year, not from this year. Not sure if you remember, but Kia had a really cool commercial. 90 seconds. I had no clue about this. 90 seconds to put a commercial on air, $12 million. Why would somebody like Kia invest that much money? What's the business hope? A lot of people see it. And what should be the next thing that they should do? They should go to the website. So half of America that is half drunk at the Super Bowl parties should go to Kia.com and figure out how cool their cars is. And next day when they're sober, buy it, okay? So they're spending a lot of money to create the largest traffic problem in the year. And they should be prepared for that, right? So what they did is what I call not really an agile deployment. And I hope for everybody of you that is having production applications, you have some type of production monitoring, where you know how fast is your website. Is it available? Or the website is down. You want to see things like this. So we from Dynatrace, we have a synthetic monitoring solution as well, but you can use whatever you want. And what you see as the next screen is our availability chart for Kia.com throughout the Super Bowl. Okay? It was 100% available, and then the ad went on air, and it dropped down to 0. So that means they spent a lot of money for me having a great story, but for me having a great story. So what happened is that they had such a great video, and they put the video on their homepage. So that means all of the people had to download the cool video content from a CDN from a different provider, but still. Everybody else that also sponsored the Super Bowl had the same CDNs. They had the same third-party components on there. That means if everybody's putting Facebook and Twitter on the same page at the biggest event in the year, then they have an impact. They are impacted the most. And if you are depending on these, then it also brings down your site. That's what happened here. Large content, cool content, but too much. Now I have a different example, an alternative, GoDaddy. What you see here is not availability, but it's response time of GoDaddy during the Super Bowl. It was about between 1.5 and 2.5 seconds. Was pretty good, yeah. What was interesting is 1 hour before the Super Bowl, the response time improved 4x. How does that work? So what said it again?
4 times as many servers.
Good idea, would be an option. What we first thought is probably their website already crashed and they're just delivering like a funny, hey, we'll come back later. That's what we thought. What actually happened, we went to their website, and what they said, if we spend millions of dollars in marketing money and we want people to go to GoDaddy, they should see what we sell. They don't need to know how many Facebook friends like us. They don't need to know what's going on Twitter. They don't need to see the high-resolution images. They can see some static version of the website. That's what they did. They said for the main landing pages, we create a scaled-down version of the website. They ran the whole thing on the same hardware 4 times faster. And they're available 100% of the time. So if you have a software where you have traffic spikes like this, then you need to consider these strategies. And 1 hour after the Super Bowl, they flipped back the switch and say full-blown version again, because now the major traffic is over. Of course, you can. Yeah, it's like eating more medicine if you are sick. No, I know, you're right. This is a more cost-efficient solution, yeah? No, but you're right. It would be an option to scale up or scale out. So the interesting thing is the key metric that told me what the difference was, the number of domains. GoDaddy went down from 26 domains where they downloaded the content to 8. So they got rid of 18 third-party domains during that 4 to 6 hours that they were no longer dependent on. Facebook, Twitter, Google, everything, they got rid of it. And also the total size was much, much smaller. So what have we learned today? Besides me being from Austria, I hope you learned a couple of metrics. And I really would appreciate if you could go home tomorrow, or go home tonight, but tomorrow when you go back to the office, pick one of these metrics and try to figure out how you can measure it on your local machine. So before you check in code, you know that you're not executing 100 SQL statements or that you don't have 500 images on that page. Then you tell your peers, and then you tell your test automation engineers that they should automatically figure out a way how to automatically capture these metrics in all the tests that you're executing automatically. So every time you're executing a test, these things are automatically checked, these metrics. Because what we want to do is we want to automate as much as possible, right? because doing things manual all the time is boring. And if you have a bad day, like maybe tomorrow, if you have too many beers, manual things are not as good as today. But an automation tool never makes a mistake because an automation tool is not drunk. And here's my point. I think this is one of my last slides that I have. If you have hopefully, who has unit tests that are executing on a build-to-build basis? Awesome. What does the unit test tell you?
We broke something, but it's not like an integration.
Like a leg. You broke a leg, or
We broke a piece of a component.
you broke the functionality, because typically what the unit test tells you is functional correctness, right? So if you have a build 17 and 2 tests and everything is green, we're good. Build 18, something fails, you know you broke something. You go back, you look at your revision log and say, what did I change? Oh, fix it, and hopefully everything will be green. And what I tell you now, I told you a list of 10, 15, 20 metrics. Why not try to figure out a way how to automatically hook up your test automation with tools that can tell you the number of SQL statements being executed, the number of exceptions being thrown, the time spent on CPU, the number of images on that page. All these metrics, if you capture them, first of all, it gives you more visibility in what's really going on. If something breaks, and you see, hey, there were 5 exceptions being thrown in Hibernate that I have not seen before because I only looked at my assertions from my X unit test, then this gives you a better hint. And if you fix everything based on your best intentions, and there the metrics tells you, well, but now we're executing 6 times as many SQL statements, and we are spending twice as much time on CPU. If you push this code forward, you know you need to buy more SQL, more database servers. So in the ideal world, you fix this right away to become back to functional green and I call it architectural green.
So when you're using JUnit in Java, it's possible to run concurrently, which really screws up your CPU time.
Yeah.
The build machine is frequently then your desktop machine.
Yeah.
So if you try some strategy like wall clock time, it frequently...
Exactly. I agree with you. So your point is, for unit tests, CPU doesn't make sense. It's more for, first of all, longer running tests, and you need to figure out a way how to accurately measure real execution time. That's one of the examples I brought in the beginning where I said the developers put in their own measuring code. Yeah. It's impacted by a lot of things. Yeah. So this only makes sense. Not every metric makes sense for every test.
And the other thing is Java has this JIT notion. And so when you go through a block of code, right?
Yeah.
The JIT occurs.
Yeah.
Now native code.
Yeah.
Come up with some strategy like throwing away the first step.
Exactly. We wrote a blog, so we use our product does this, and we use our own product in our own development team, and we actually wrote a blog about how we actually do it internally. So we have some warm-up tests to make sure that the system is stable, and then measure. But for most of these metrics, number of SQL statements, it doesn't matter if it's cheated or not, or if it runs on a virtual machine. These are hard metrics, but these are more. Does this make sense? Okay. And I guess you can figure it out. If you have a build pipeline, then you can use all of these metrics as additional quality gates. So if you're responsible for your build pipeline, do not only use the result of your JUnit tests or whatever tests you use as functional quality gateways, but look at these metrics as well. And block this build if you know you've just introduced an architectural regression because you're executing 5 times as many SQL statements. If you know this already, there's no need to waste time in capacity testing because they will find the same problem. This is basically reducing what's called unplanned or wasteful time. It's wasteful because we already know it. All right. You're still awake, at least most of you, as I can see. I hope this was, I hope at least that something of this was new for you, not only repetition. I do this on a day-to-day basis, so I help people all the time, and I know, I can look at this data and I know what's going on within a couple of minutes. That's also why I offer what I call performance clinics. So in case you're trying, tomorrow you decide, or next week you decide to actually look at things like this, instead of you going through the pain and figuring out all these metrics on your own, I'm offering what I call an online performance clinic every other week. So by the way, these links, I'll put them all up on Meetup in case you're interested. So I do a webinar. They're also recorded and put on my YouTube channel. So you can look at things like how I do diagnostics of multi-thread applications and stuff like that, how I hook up JUnit with diagnostic tools. And also in case you decide, because the tool that I present, this is my only marketing thing, Dynatrace is a production monitoring performance tool. So we are monitoring applications in production end-to-end, but not only in production, but also in test and development. So all the use cases, the screenshots were from Dynatrace. And the cool thing for you is you can sign up for a free trial. You get 30 days on a distributed app, and after 30 days, the tool stays free for you on your local machine in case you want to test it out. So in case you said, why do I waste time on an evaluation if after 30 days nothing works anymore? After 30 days, it keeps working on your local machine, means you can analyze anything on your local machine as long as you want. And if you have no idea what the data tells you, I have a Share Your PurePath program where you can actually send me the data, and I'll send you back a PowerPoint similar to what you saw today with bullet points saying this is a problem, this and this is a problem. So there's a benefit for you and a benefit for me because I have new blog material for next year. And maybe you invite me again back next year and I say, these are the top performance problems from San Francisco. And then we can do a competition. Okay. All right. That's it. And I hope this was useful. If there are any questions, let me know or feel free to escape, but grab a beer. There's still some left. Any questions? What do you do? Actually, so yeah, good question. So for your case, so he was asking about garbage collection. What's the right approach? Is it about tuning or is it about being smarter with object creation? We actually have an online performance book where one of my colleagues, he's an expert in Java memory tuning. It's a free book. It's on book.dynatrace.com. It covers all of this also with use cases. And on our blog, we also have a lot of examples. Exactly. Yeah, if your object churn rate is really high, if you're constantly creating and destroying objects, exactly, yeah. And I'm sticking around for a little longer. So those of you that really want to leave, feel free. In case you if you don't want to remember the URL, so wait until I post it. I also have some cards because you can feel free to take them. There's some information on there. And I'm really happy to find out new problem patterns. All right, thank you.